In nature, atoms always want to be stable. One way they can achieve this is by having a full valence shell, meaning they have the maximum number of electrons possible in that outermost energy level. The octet rule states that atoms are going to bond in such a way as to have 8 electrons in that valence energy level. This is sometimes called the rule of 8. If we take a look at a chlorine atom and look at its Bohr diagram, we see that chlorine atoms have 7 electrons in their valence shell. These are represented in purple, and we can count them out. We have 1, 2, 3, 4, 5, 6, 7. This corresponds to the 7 electrons shown in its electron dot diagram. So a chlorine atom isn't fully stable because it still could have one more electron. If we take a look at the periodic table, we see that the nearest noble gas to chlorine is argon. Argon has a full outermost valence shell. So if a chlorine atom can gain one more electron, its outermost energy level is going to be full and it's going to be more stable. This is how ions are formed. So an ion is just some kind of atom or molecule with a net electric charge. And it has a charge because the number of protons no longer equals the number of electrons. An anion is something that has a net negative charge, so more electrons than protons. And a cation is something that is net positive with more protons than electrons. So if we take a look at chlorine and we see that it has gained one electron, taking a look at this Bohr diagram in its outermost shell for a chloride ion, we see it has 1, 2, 3, 4, 5, 6, 7, 8. So it has one more electron in that outermost shell than the chlorine atom. So this is an example of an anion because it has a negative charge. We have more electrons than we do protons. In this case, we have 17 protons. That's not going to change because that's what makes chlorine unique and correspond to chlorine. However, the number of electrons in the outer shells has increased by 1, and now we have 18 electrons and only 17 protons. The number of negative charges now outnumbers the number of positive charges by 1. Now, if we want to draw an electron dot diagram for a chloride ion, what we're going to do is the same thing as before. We're going to draw the symbol for chloride is Cl, but we're going to draw in all those electrons. Now we have that extra electron that wasn't previously there in the atom. So then we're going to draw these brackets around that and put the negative charge. So since we have one more electron than we usually do in the atom, it's going to have a charge of 1 minus. Notice that for negative charges, chemists always put that negative sign after the number. It's weird, it's kind of different, but that's what chemists do for electrical charges. So a chloride ion has an overall net charge of 1 minus. So that's how we draw electron diagrams and a little bit of an explanation of how atoms and ions differ.